All right, we are on Unit 2, Day 7. Today, we're going to be learning about functions and function notation. Let's go to your Unit 7 warm-up, the notes section of it. So we're going to start with this top part here. It says there is a correspondence from one set to another, much like there is a correspondence from the first coordinates of an ordered pair to the second coordinates. So what that means is there's a connection. And that connection, the first example says, for every person in class, there corresponds a mom. Obviously, we need to have a mother in order to be born. So that's a direct correspondence there. Or for each item in a store, there needs to be a price. Okay, so if I'm buying a Snickers bar, there's a price. If I'm buying a Twix bar, there's a price as well. It could be the same price. That's okay. But for every item that you choose, or the first thing that you choose in a store, it's got to be attached with a price in order to pay for it. And then for every real number, there needs to be a cube of that number. So that means like 2 cubed would be 2 times 2 times 2, which would give you 8. Or 3 cubed would be 3 times 3 times 3. So there's always a correspondence with many things in life. Those are just 3 examples. We're going to go through a lot more. But when you have one correspondence, or where every input has an output, a unique output, then that's considered a function. So that's the first thing that I want to write down here, is that this function is an equation where each input, input, and typically it's like an x value. So the inputs would be our x values, because that's what you plug in to like graphs. You'd find or you'd have an x value and you plug it in, you get a y value. And it has, so each input x value only has one, or has only one output. So if you plug in 1 for x, you're going to get something for y. If you plug in 2 for x, you're going to get something for y. So when I'm talking about this, as an example for me would be not only the ones above, but I think one that we can all agree on would be the vending machine. So you have your input. So you put your money in and then you plug in a number. Or I think it's, is it a letter and a number? I can't remember. But you have this letter and a number, and then you have an output, which would be the thing that you get. So that would be considered a function, because if you plug in a number, you're going to get the thing that you want. If you plug in a number and it would be random, that something would fall from the vending machine, but it's not the thing that you plugged in, that's not considered a function. So a function always has an input that's attached to one unique output. So we're going to go into that in a little bit more detail a little bit. So domain are always my inputs, or if you think about it in terms of an equation with a graph, these are always my x values. So that's always going to be my inputs, and my range are my outputs. So that's what you get out. So that'd be my y values. So that's 2 vocabulary terms that are often used from here on out in your math career. That domain is your x values, your inputs, and range are your y values or your outputs. So when we are asking for our domain and range, we're going to always write these numbers or values from smallest to largest. Oopsie. Largest. And then if you see the same number twice, you don't need to repeat it. So that's the other thing that we're going to write here. You don't need to repeat the same numbers. So we only got to write it once if they're asking for the domain or range or your inputs and outputs. So here's a key part of if it's a function or not. It's not a function if the input, so that would be your x value typically, or the number that you plug in first. So if the input is connected to two outputs. So an input can only be connected to one output. So that example that I go back to is the vending machine example. If I plug in like A1, there shouldn't be two possible things that would drop from the vending machine. It should be the thing that you want. So that would be considered a function because when you plug in a letter and a number, it goes to one single thing. But it wouldn't be considered a function. And the vending machine wouldn't make sense if you plugged in A1 and there could be two different things that would drop because you might get something that you don't want and you'd be upset. So let's take a look at these examples here using our vocabulary. So domain are all my inputs. So that'd be the numbers on the left that you start with. So if we write them in numerical order or from biggest to smallest value, it's in numerical order for me from top to bottom. So my domain are all my inputs or x values. In this case, -3, 1, and 4 are what I start with. And my range are all my outputs. So that's what these are going to. So if it's in numerical order, I see a 2 and then a 5. So those are my two different numbers that I have. So now is this a function? So is every input connected to an output? Well, 3 is connected to 5, 1 is connected to, and 4 is connected to. So that works. When it wouldn't work would be if we had 1 is connected to 2 and 5. If that was the case right there, what I just drew in, then that would not be considered a function because 1 would be connected to two numbers. So I don't care that the outputs over here have two arrows pointing to them. So like in this number 2 here, that's okay to have two inputs connected to the same output. That's fine. You just couldn't have two lines connected from the same input going to different outputs. That means it would not be considered a function. So let's take a look at number 2. Number 2's domain are all my inputs, or x values in this case. We start with -2, 0, and 2. Those are all my inputs. My range are all my values on the right side. So we have -4, 0, and 4, and that's in numerical order from smallest to biggest. And then my function, or determining if it's a function, you have to ask yourself, is every input only connected to one output? Well, the problem here that I see is this number -2. It's not only connected to 4, it's also connected to -4, which would not make sense in that example, once again, of the vending machine. Now, so if you plugged in -2 as your input, and then you got two different things out of it, wouldn't make sense. Now for number 1, though, sometimes the vending machine actually has like the same thing, like Cheetos, in two different spots. So this number 1 could go to Cheetos and the number 4 could go to Cheetos, and that's okay. That makes sense. But for number 2's example, this -2, you can't plug in and get possibly two different things out of that. It would not make sense. So this is a no for a function because every input doesn't have one unique output. The -2 has two outputs. Now let's take a look at number 3. Number 3, we don't have a numerical order, so I'll put it in alphabetical. So we have Chicago, we have New York, is all my inputs, and we have San Francisco. And then my range or my output. So what are they pointing to? Well, they're pointing to the Cubs and the Giants and the Mets. So those are the three teams on the right side. So now let's take a look. Is every input connected to only one output? Well, San Francisco is only connected to the Giants. That's good. Chicago is only connected to the Cubs for this example, so that's good. But New York is the issue. It's connected to two. Once again, that would go against the vending machine example. So this is a no, because one of your inputs has two different outputs that it's connecting to. So that would not make sense. So this next part is talking about how do we determine if something is a function. There's a couple different ways. The first way we've talked about that each input has only one output. Each x value, which is the same thing as an input, has only one y value. And each code in the vending machine is connected to only one item. So that's the example that I used a bunch of times. So that's functions in a nutshell. Now the next page just goes through some examples like above. So we'll take a look at some of these. So let's go down here. Let's zoom in on number 1. So it says state the domain, the range, and determine if it's a function or not. So number 1, I'm going to write these as ordered pairs in this little, the boxes they give us. You don't have to, but I think it makes it easier to see if there's any doubles and if something is a function or not. All right, so let's take a look. So that's in numerical order for your domain. So that's -8. We have -3, 0, 1, and 5. And then my range value, the smallest number is -6. Then it goes -3, 1, 2, and 10. So does every input, so do all these x values only go to one y value? Yeah, that looks like -8 goes to 10, -3 goes to 2, 0 goes to 1, 1 goes to -3. Now, if you had any repeaters on the x values, so if you had like another number down here, like 1 goes to 4, that'd be an issue, because then you'd see that 1 goes to -3 and 1 goes to 4. So that would be a no if that was the case. But in this case, it's not there. So we're good. So this answer is yes, it is a function. So let's go over to number 2. So I'm going to write them in numerical order for my x. -3, 4, 0, 8, 1, 2, 1, 7. Oopsie, that 7 is gigantic. 7, and then 3, 5. All right, so let's take a look here. My domain are all of my x values in order. So I have -3, 0, 1, and 3. You don't have to write the 1 twice. If you see it twice, you just have to write it once for your domain and range. My range in smallest to biggest is 2, and then 4, 5, 7, 8. Now we have to ask ourselves, is every input connected to only one output? Well, we have one that's connected to two different outputs, so that's an issue for us for our function. One is connected to the number 2, and one is connected to the number 7. So this would be no, it's not a function. Does not work. All right, so why don't you guys pause and try these next two on your own, and I'll do them quickly for you over here as well. 3, 0, 0, 1, 3, 2, 6. My domains, -8, -5, 0, 1, 2. And then my range is 0, 3. 3 shows up twice. I'm only going to write it once. 6 and 7. Are there any repeaters? Nope. So the answer is going to be yes, it is a function because all of your x values only show up one time. So that should be the answers you got when you paused. And then this last one, domain, if I don't use the table, is 4, 6, 11, and 15. And my range is -2, 0, 7, 8, 9. It's a little bit harder without using the table. So let's see, are there any repeaters on my x values? Oh, I think so. We got one here and one here. 11 goes to 9 and 11 goes to 0, so that's a problem. So that's going to be a no. All right, so then 5, 6, and 7. They already have the tables done for you. So I'll do number 5 here in order, 0, 1, 2, 3. And then my range in order from smallest to biggest is -7, -3, 2, 3, 4, 8. Are there any repeaters? Yeah, we have the 0 and we have the 2. So that one's going to be definitely no, because not every input has one output. 2 goes to 8, 2 goes to 4, and 0 goes to -3, and 0 goes to 3. So that's a no. 6, we just write them in order, and same with 7. I'll tell you whether or not they're a function just looking at them. It looks like there's no repeaters in number 6, so that's a yes. And then it looks like 8, 10, 15, 17, 8. There's no repeaters for 7, so that's also a yes if you went through that. And then number 7 is similar to what we did on the front of this. So we have -6 goes to -8. We have -6 going to 11. We have 3 going to 11. And 7 going to 22. So my domain would be -6, 3, and 7. That's kind of an ugly 7. Most of my stuff is, though. And then my range is -8, 11, and 22. So are there any repeaters on my x? So, well, these two. -6 input goes to -8, and -6 goes to 11. So that's a no if you have any x values. So that's everything.